This is Pre-Calc section 6.8, partial fraction decomposition part 4. What we're going to do here is another example with a quadratic factor where at the end we're not going to just let x equal 0, 1, 2, 3, whatever we want. We're going to use a method called equating coefficients. So the beginning of this starts the same. Here's our denominator. Here's our x plus 4, which is a linear factor. So the linear factor will get a. This is a quadratic factor, and when there is a quadratic factor, the numerator has to be of this form, bx plus c. We still need to clear out the fractions by multiplying both sides by the common denominator. So let's type in this a and the bx plus c from the other page. And then we're ready to clear out our fractions. When you multiply on this side, this whole denominator cancels with this whole denominator, which gives us 3x minus 2. Over here, the x plus 4 will cancel with that x plus 4, so that's gone. And what you have then is a times 3x squared plus 1 plus, then we want to multiply here, and the 3x squared plus 1 will cancel. And you have the binomial bx plus c times the binomial x plus 4. Now in the other method where we were letting x equal something and substitute in, we left it in this factored form. If we're going to go to the method of equating coefficients, we need to distribute here and FOIL this out right here, which left side stays 3x minus 2. Distribute the a will be 3a x squared plus a. FOIL over here, bx times x is bx squared. Bx times 4 is 4bx. Then c times x is cx, and c times 4 is 4c. I cannot emphasize enough how important it is to go back and double check your work with the foiling and the distributing, because if you make one little mistake with that, it throws everything off. Now this next page is the same thing I have there, but that's all I have on the page, so I've got more room. What we want to do here to do this equating of coefficients is you want to gather up like terms in terms of this. These are both x squared terms, so I'm going to write this as 3ax squared plus bx squared. And then I cross these out because it's very easy when there's so many terms to lose something along the way. So that's the only x squared items I have. Then I have these that are the x terms. So this is plus 4bx plus cx, and cross those out. And then a and 4c are the only ones that are constant. So plus a plus 4c, still equal to 3x minus 2 on this side. Now within here, I need to factor out the x squared. So factor out x squared, I will have 3a plus b. Here, factor out the x, and I will have 4b plus c, and then there's nothing to factor out here because a plus 4c is just my constant. Now, the process called equating of the coefficients is this. This is some coefficient times x squared. We do not have an x squared term over here, which means 0 equals 3a plus b. That is equating the coefficients. This is the coefficient of x squared. The coefficient of x squared over here, if you want to write it, is 0. So that's one equation I'll deal with in a minute. Then over here, the coefficient in front of x is 4b plus c, and it must equal the coefficient over here that's in front of x, which is just 3. This is my constant term, which is a plus 4c, and it equals -2. So that's the process of equating coefficients. I now have to do some solving with systems and substitution to be able to find my values for a, b, and c. Look at these three thinking maybe I can put together a system of two equations and cancel out a variable, but the problem is this one has a and b, this one has b and c, this one has a and c. So I'm going to have to do some substitution before I can get into the system of equations. What I see right here is that I could solve this equation for b by subtracting 3a from both sides. So b equals negative 3a. And what does that do for me? That allows me to substitute the b value in for that. So this will be 4 times negative 3a plus c equals 3. Multiply 4, and I get negative 12a plus c equals 3. Now the reason that was a good idea is that now this is an equation with two variables, a and c, and over here is another equation with two variables, a and c. I can put these two equations together in a system and use elimination or substitution and solve. So I have a plus 4c equals negative 2. This is negative 12a plus c equals 3. So I'm going to just multiply this one all the way through by 12, because that'll be positive 12a plus 48c equals negative 24. The a's cancel out. This gives me 49c equals negative 21. Divide by 49 and simplify by 7, and I get c is negative 3/7. Where I go with that can go into either one of these to solve for a. I'm going to plug into the top one because I'm going to be using this to solve for a, and this equation a doesn't have a coefficient, so that will make the solving a little bit easier at the end. So this is a plus 4 times c, which is negative 3/7, equals negative 2. So multiply 4 times negative 3/7 is negative 12/7 equals negative 2. Add 12/7 to both sides, so add it over here, that'll cancel this out. And this will give me negative 2/7. Use your calculator to do the fraction arithmetic if you need to. So I have values for a and c. To get a value for b, I'm going to plug my a value right here. So this is negative 3 times negative 2/7 equals b. Multiply, that gives me 6/7 equals b. So I've copied this information on a clean page here. Here were my values of a, negative 2/7, b was 6/7, c was negative 3/7. This was our basic format from the first page, so all I have to do now is plug this in for a and these values in for b and c. So that will give me negative 2/7 over x plus 4 plus 6/7 for b, x, minus 3/7 all over the quadratic 3x squared plus 1. Bring those denominators down, and I'll have negative 2 over 7 times x plus 4 plus 6x minus 3 over 7 times 3x squared plus 1. So